Good morning, class. In today's video, we're going to be looking at nested loops notes 2. So we're going to be going over a couple examples of utilizing nested loops, which could be while loops, for loops, do while loops. Okay, so first we're going to do, we just create a scanner because we're going to utilize user input. Now, my first example uses a do while loop, and you can see it ending down here. Remember, with the do while loop, all of this code runs at least once. And once we hit the while loop, if it's true, it'll go back to the do and start over. And also remember, with the do while loop, the while itself here has a semicolon on it. All right, so let's look at what this example is doing. So we ask the user input in a positive number. If they input -1, we want the loop to end. So if x is less than or equal to 0, I hit continue. Now what continue does is, if this is true, the continue causes me to go immediately to my while statement and check the condition again. If the condition's true, go back to the do, start again. If the condition's false, we leave. So if the user enters a -1, this will be true, so I'll go to the continue. This will check, hey, -1 doesn't equal -1 is false, so the while loop ends. All right, and so if I enter a negative number, the while loop reruns, so this will rerun if it's like -5, but if it's -1, the while loop will end. All right, so if I enter a positive number, what does this code do? So it's a fairly simple code, similar to one of your previous labs. All it's going to do is printing out 1 up to that number. So if I enter 7, it'll print off a 1, a space, a 2, a space, all the way up to 6 space 7. Fairly simple. Fairly simple. But again, you can see how this idea works. So again, I can input as many positive numbers as I want, and it'll print off 1 to that positive number. Eventually, when I'm ready to stop, I'll input -1, which will hit this, which will cause this while loop to end. All right, so that's one example of a nested loop. Again, you've got your outside loop and your inside loop. Your inside loop will run its full iteration every single time the outside loop runs once. Of course, assuming this was false, and we get past this if statement and don't do the continue. Okay, so let's look at the next example. This one's a little bit more complicated looking. We started off with while true. Now, since this is a while loop and just saying while true, this while loop is going to run infinitely. So that means I need some sort of break for it to end. Now, I did this a little bit differently than I normally would have, how I did the break, because you'll notice I didn't put the break inside an if statement. And then the reason I did that is because I wanted to demonstrate, again, a use of a continue. So here, if this statement's true, I do the continue, which will cause me to rerun the while loop. So I only can get here if this is false. All right, so let's look at how this one works. I'm asking the user to enter a number from 100 to 999. So I'm asking the user to enter some 3-digit number. Now, I'm not going through checking here, make sure that they entered a positive number. I don't really care for the sake of this example. So I'm going to go ahead and just assume that they entered a positive number. And I'm doing something that we did previously in a lab, which was determine whether a number was a self-divisor or not. And so I can input as many numbers as I want, and this will quit only if the number is a self-divisor. So if I enter a number that's not a self-divisor, it'll rerun. So I store the original value of x into this original variable. I have a Boolean determining whether it's a self-divisor or not. My while loop is going to run while x doesn't equal 0, because the moment x is equal to 0, I've divided by 10 until x is empty. So I get the ones digit stored into variable digit. I divide x by 10. If digit is equal to 0, you can't divide by 0. So this statement's true, because again, look, I'm using the double or sign, So if that's true, it doesn't check the second part. But if this is false, I then see if the original modulo digit, I'm seeing if the digit goes evenly into original. If it doesn't go evenly into the original, the number's not a self-divisor. So I set this to false and I break, which means I'm going to break out of this while loop. One thing with breaks and nested loops is you always break out of the current loop you're in. So this break is in this loop, so it breaks out of that loop. If it's not a self-divisor, I print out, hey, it's not a self-divisor, and continue. If this is false, that means it is a self-divisor. So I print as a self-divisor and I break, which causes me to leave the outside loop. All right, so here's two examples of looking at ideas we've done previously in labs and just implementing them so that they were nested loops, so you could keep inputting numbers until a certain thing happens, such as you input -1 to stop, or you input a self-divisor. But let's demonstrate these in action. Let's show them running. So you can see here we're asking user to input a positive number. All right, so let's say we input 7. And you can see it just prints off 1 through 7. If I input -5, it doesn't print that. I can print another number, like, okay, 14. Then eventually I'll input -1, and I leave that first one. Now it's asking me to enter in a 3-digit number, and it's going to keep asking me to input a 3-digit number while that number is not a self-divisor. Like 120 is not a self-divisor. 126 apparently is a self-divisor, and it causes it to leave. So there we go. There's nested loops note 2. Remember, you can have any loop inside of a loop, be it a while loop, a do-while loop, or a for loop, it doesn't matter. In this class, we're never going to do more than one loop inside of another. So you're always going to, so at max, you're going to have one outside loop and one inside loop. Though you could have a scenario where you've got multiple loops, you know, inside an outside loop. But again, you have it like this could be, you could think of this as like the first inside loop, and then this is the second inside loop, but they're not inside of each other. That's the max that we'll have in this class. All right, thank you very much, and have a good day.